Hello my students, I'm Mr. Tariq and welcome back to my channel. In this video I'm going to explain arithmetic and geometric sequences and solve problems for both. So first we need to learn arithmetic sequences. An arithmetic sequence is a sequence of numbers where each term increases or decreases by a constant difference d. So let's take an example. 1, 4, 7, 10, etc. So this is a sequence and it's an arithmetic sequence because each time it increases by a constant value. So the constant value here is 3 because we just add 3 each time. 4 plus 3 is 7 and 7 plus 3 is 10 and so on. Also we have general formula for the nth term. So in our example here, in this sequence, we have the first four terms. 1, 2, 3, 4. So to find the fifth term, we simply just add 3 and we can find that it's 13, and also for the sixth term and so on. But if we want to find something far like the 20th term, so the 20th term will take a lot of time using this method. So in this case we have to use this formula here. An equals to a plus n minus 1 times d, where a is the first term, d the common difference, n is the term number. So in our case here we just sub n with 20 and d is the common difference, which is 3, and a is the first term, 1. And to find the sum of the first n terms, we can use this formula as n equals to n over 2 times 2a plus n minus 1 times d. So for any sequence, we can easily add the first 3 or 4 numbers, but if this extends like for 10 terms, this is going to be difficult. So we need also to use a formula to make it easy. And I will explain all of this in the coming examples. Example number 1, the first term of an arithmetic sequence, so its arithmetic sequence, is 5, and the common difference is 3. Find the 10th term. So first, to find the nth term, write the formula. If you remember the formula, an equals to a plus n minus 1 times d. Now we need to extract these values from the example. So the first term is 5. That means a equals to 5. And the common difference is 3. So d equals to 3. And we need to find the 10th term. That means n equals to 10. Now let's solve the equation. So a10 equals to a is 5 plus n minus 1 is 10 minus 1 times d, which is 3. So equals to 5 plus 10 minus 1 is 9, and 9 times 3 is 27. That equals to 32. So the 10th term is 32, and this is our final answer. Example number 2, find the sum of the first 20 terms of the arithmetic sequence 2, 5, 8, 11, etc. So let's write the formula of the sum. Sn equals to n over 2 times 2a plus n minus 1 times d. And now we need to find these values. So the sum of the first 20 terms, that means n equals to 20. And the arithmetic sequence is 2, 5, 8, 11. So 2 is the first term. So a equals 2. And we need to find the common difference, d. So 2 plus 3 is 5, and 5 plus 3 is 8. That means d equals to 3. So S20 equals to 20 over 2 times 2 times a, that means 2 times 2 plus n minus 1, 20 minus 1, times d times 3. 20 over 2 is 10 times 2 times 2 is 4 plus 20 minus 1 is 19, and 19 times 3 is 57. That equals to 10 times 61 equals 610. So the sum of the first 20 terms is 610. And this is our final answer. Now the second part is the geometric sequences. So a geometric sequence is a sequence of numbers where each term is multiplied by a constant ratio. So the difference between this and the arithmetic sequence is increases or decreases by a common difference. But here we have a constant ratio. So for example, if I have a sequence start with 2, then 4, 8, 16, and so on. So from 2 to 4, we multiply it by 2. And from 4 to 8, we multiply by 2. 8 to 16 multiply by 2, and so on. So this sequence is a geometric sequence because each term is multiplied by a constant ratio r, and in this situation is 2. So the general formula here for the nth term is an equals to a times r to the power m minus 1. We know that a is the first term, r is the common ratio, and n is the term number. We can also find the sum of first n terms for a geometric sequence. So Sn equals to a times 1 minus r to the power n over 1 minus r. And r is not equal to 1, because if r equals to 1, that means there is no sequence. Another sum formula we have here is sum to infinity. So S infinity only when the absolute value of r is less than 1. So S to infinity equals to a over 1 minus r. So the absolute value of r less than 1 here means r is always a fraction, because any fraction, positive or negative, the absolute value of it is always going to be less than 1. And let's explain with examples. Example 3, the first term of a geometric sequence is 4 and the common ratio is 3. Find the sixth term. So let's write the equation for the formula. So an equals to a times r to the power m minus 1. So the first term is 4, a equals to 4. The common ratio r is 3, r equals to 3. And we need to find the sixth term. That means n is 6. 6 equals to a 4 times r 3 to the power m minus 1, 6 minus 1. So 4 times 3 to the power 6 minus 1 is 5. 3 to the power 5 is 243. So the final answer is 972. So the sixth term is 972, and this is our final answer. Example number 4, find the sum of the first 5 terms of the geometric sequence 3, 6, 12. So Sn equals to a times 1 minus r to the power n over 1 minus r. The first term is 3, that means a equals to 3. So r is the common ratio, so 3 times 2 equals to 6, and 6 times 2 equals to 12. That means r equals to 2. And finally, we need to find the sum of the first 5 terms. That means n equals to 5. So let's sub the values here. It's 5 equals to 3 times 1 minus r to the power n. It's 1 minus 2. I just keep write the letter. 2 to the power n. N is 5 over 1 minus r. And that equals to 3 times 1 minus 2 to the power 5 is 32 over 1 minus 2, 3 times. So 1 minus 32 is negative 31 over 1 minus 2 is negative 1. So that means 3 times. So negative is negative, is positive, so 31. And this is equals to 93. So the sum of first 5 terms is 93, and we are done here. Example 5, find the sum of infinity of the geometric sequence 10, 5, 2.5, etc. So let's write the formula. We have S infinity equals to a over 1 minus r. Now a is 10, so r is the common ratio, and we have 10 to 5, we multiplied by half, and from 5 to 2.5 we also multiplied by half, and the absolute value of this half is less than 1, so we are okay. So r equals to half, or 0.5. Now let's sub the values here. So s into infinity equals to a is 10 over 1 minus half, so equals to 10 over half. So 10 over half means 10 times 2, so equals to 20. So the sum to infinity is 20. And this is our final answer. So that will be the end of this video. Thanks for watching, and I hope you enjoyed this lesson. If you found it helpful, give it a thumbs up and subscribe for more videos. See you in the next video. Bye.